Okay, chapter 4, day 4. What we're going to look at today is how do we perform function transformations. So how do we take those parent functions that we wrote down the other day in our notes, and how do we transform them, and what happens to the equations when they do get transformed. So for example, so we start with some function. I don't care what the function is. We start with a parent function. Could be x squared, could be square root of x, it could be just x, it could be 3x, 4x, it could be absolute value x, but we have a function. Now, if we take that function and we tack on a value, some number like plus 5, so x squared plus 5, what happens is the graph shifts upward that many units. So no matter what the graph is, if I add on, the graph moves up. All right? So whatever parent function I have, the graph will move upward how many ever units I said. If I subtract off a value, the graph moves downward. Okay? So at the end of the problem, like x squared, plus 5 moves it up 5. Minus 5 would move that same graph down 5. All right? Now, let's say I do a plus a number, but notice it's inside the parentheses now. It's not tacked on at the end of the problem. So this could be like parenthesis x squared plus 5. Or parenthesis, or like absolute value x plus 5. So when it's within parentheses with the variable, adding makes the graph move in the opposite direction horizontally. So if I do plus a number, it moves back on the x-axis towards the negative that many units. So if I do plus 5, the graph shifts actually in the opposite direction, 5. So if a is inside the parentheses, it moves in the opposite direction that we say that this is. So if it's plus, the graph slides towards the negative. If it's minus, the graph will slide towards the positive. All right? So f of x minus a, the graph actually moves rightward that many units. Okay? Now, what if we negate the function? If we negate the function, the graph reflects across the x-axis. It flips. All right? If it's down here, it flips up. If it's up, it flips down. The graph reflects across the axis. All right? If we negate inside the parentheses, the graph will reflect across the y-axis. So if it was here, it flips and goes over here. So this is negating the entire function. This is negating within the parenthesis. Okay? Outside the function, flips across the x-axis. Inside the function, flips across the y-axis. If I put a multiplier in front of the function, it makes the graph steeper, and you'll see that with absolute value graphs. They'll get steeper as the multiplier goes up. Okay, you'll see it with parabolas, they'll get steeper. You don't see it much with straight lines. You'll see the slope will get steeper if it was a straight line. But mostly with your absolute values and your parabolas is where you're going to see the steepness. Now, if a is bigger than 1, like if you have a 2 times your x squared function or a 3 times your x squared function, it's going to get steeper. But if that number is between 0 and 1, like a half or a third or 0.75 or 0.25, okay, it actually flattens the graph out and makes it shallower if the multiplier is between 0 and 1. Let's take a look at a couple examples. So here's a function, all right? and I need to write the equation of that function. So I first have to decide from my parent function list, what kind is this? And from my parent function list, the v, if you remember, is the absolute value of x. Okay, that's my parent function. So my equation will have some sort of absolute value. But is this absolute value right here on the 0? No. What did it do? It slid to the right 3 places. Okay? It started at 0, it didn't go up, it didn't go down, it just slid to the right 3 places. All right? Well, let's go back. These outside slide it up or down, this one slides it left and this one slides it right. So if I moved this way, then I must have my parent function minus how much it moved. So I go back to my graph. This equation must be absolute value of x minus 3, and that's the equation. Because I took the original parent graph of an absolute and I slid it 3 units this way. And that's the equation, x minus 3. So you need to identify the parent function so that you can then write the equation. Let's take a look at another one. Here's another absolute value graph. Okay, so y equals, well, I know it's absolute value, but let's see what's going on now. It's absolute value of something. Okay, so if I take a look at my parent function, all right, the function slid over and then flipped. Okay? The function moved and then flipped. So to move it 1, 2, 3, 4, that means I have to have x minus 4, because minus moves it in the opposite or positive direction. And I now have to reflect it over the x-axis. All right, I need to take this and flip it over the x-axis. Notice it's flipped. Okay, so I flipped it and I moved it. Let's go back to the rules. We got to find which one flips it. Ah, here we are. Negating on the outside of the function flips it. So go back to our equation. So this is going to be negated on the outside, absolute value x minus 4. So we've flipped it and slid it over 4. All right. Here's another one. Ooh. We have, looks like we've flipped it and we've slid it left and right. Okay? So let's think about what that would be. Y equals, it looks like my parent function is still the absolute value. Okay? I have moved the graph 3 now to the left, so that means I must have added 3 inside. I have moved the graph down 2, and so if I go back to my parent function rules here, or for my transformation rules, moves it down means I tack a minus on at the end, moves the graph down. So I move it down 2, but it has been flipped, so therefore negate. And that is the equation. You can take a parent function now, and if you know the rules about what happens inside the parent function and outside the parent function, you now can write the equation. The graph has been flipped. The graph has been moved to the left 3, and then the graph has slid the whole thing down 2. So last one. Notice new parent function. Well, parent function there, if we remember, is x squared. Okay? But the graph has been shifted. So the graph has been shifted to the right 2, which means minus 2. And there's my graph. I shift the parent function, and the parent function is x squared. If it had been moved up or down, then this value would be tacked on the outside. But it didn't. It stayed right where it was, and it just slid over 2 units. We're going to practice a bunch of these in class.